ladies and gentlemen, welcome back. Today we have something somewhat of an unusual project. As you can see, we have a fairly unusual implement here for our projects, and that's actually a cast iron skillet. So what are we going to cook today? Well, let's see. Ta-da! What you can see here is actually our lithium polymer battery from the iPad that we just assembled. And that's not just a skillet. In this case, that's going to be our containment device. So what we're going to try to do today, I can say that I do not recommend you try this at home. I wasn't sure if I want to pause this video, but I figured, hey, what the heck? I would like to do it anyway. You know you want to do it, and it's better you just watch it and me doing this, and I'll try to do it as safely as possible. So the thing is, this battery, what I pulled from the iPad, is pretty much dead. I mean, not unexpectedly so, and I already hooked up it directly to the terminals of the battery itself. I mean, I can show you again. Basically, there are terminals, there are two cells there, and they're hooked up in parallel. So it's 1S 2P configuration. So it's 3.7 volts pack of about 6.2, I believe, 60 to 100 capacity. So the leads are going to be right here. Never mind the colors. These colors are correct at the end. So that's the positive connection to the battery. That's the negative. But look what we have for the actual voltage. 0.008. Yeah, that's pretty much dead. Generally speaking, you are not supposed to be doing anything with these batteries, just recycle it, and that's actually what I'm going to do. I already have a new battery for the, well, new to me, workable battery. So regular chargers would not charge the cells that are that low, but there are plenty of videos that you can see where people recover lithium batteries from the dead. Basically, what you need to do is to bump it, to provide some initial charge, to raise the voltage to the level where the regular charger can pick it up. And again, that's not necessarily the safest thing to do. However, based on some research, the dangers of that are somewhat overblown. So basically, the biggest problem with the charging of where the actual danger is then you have batteries in series and some of the cells getting reverse charged. So basically, the current flows in the opposite direction where it's supposed to go from the charging perspective. And that's where things really go pear-shaped. The internal shorts for the deeply discharged batteries may happen, but generally speaking, what it leads to is much faster discharge rates and a lowered capacity. In any case, so we'll see what we can do with this battery, if anything. So again, the skillet is here. It's cast iron. It's pretty heavy, thick walls. So if anything catches on fire, explodes, it's pretty well contained here, and I can, in a matter of seconds, throw the whole container outside. Again, one way how people do that is hook up a working battery in parallel. And that is not a great idea. The reason being that when you connect the completely depleted battery with the working battery, there is a rush of current, which is basically not limited at that point in time, or not much, from the working battery to the discharged battery, and that's actually bad for both batteries. And yeah, that can turn ugly as well. So what you want to do is to charge with regular voltage and the current limiting power supply, or you can J-rig one yourself, obviously, with the resistors and just regular DC power supply of sorts. And you want to go low max amperage for that stage, and literally spend as little time in this initial bump phase as you possibly can until you get the voltage to on the depleted cell to 2.5, 3, whatever is the cutoff on your charger for lithium batteries, and then see if it can pick up from there. What we have here is the iCharger X6. That's the balancing charger for the lithium, well, actually for all kinds of chemistries battery packs. We're not going to be using the balancing feature here. However, the one feature we're going to be using here is actually it can work as a power supply with the voltage and power limiter. So yeah, all this junky wiring, obviously, not ideal, but we are not expecting massive currents here. Again, we even in subsequent charging process, we would want to go as low current as we can reasonably, because yeah, we don't want to stress this battery. Right, and we managed to switch to the LiPo charging. And now, as you can see, it did catch it. It figured that the cell is pretty low on charge, so it's pre-charging. It's pre-C. So basically doing automatically the same thing we have done right before that, except we did it from a much lower level. The bottom line is, yeah, it dipped down. I think it's 2.8 was the cutoff right now in the settings. And yeah, you can see it's still, well, now it stopped charging, and the voltage is dropping like a stone still. So yeah, and nothing exploded. I can show you. It's a little bit anticlimactic, but yeah. You see no damage to the battery. It's not even warm, not puffed. Yeah, it just not charging. All right, and we're back, and some changes to the where we left last time. So I said that basically the battery is junk, and that is still accurate. However, I thought like, hey, you know what? Didn't get any explosions yet. What the heck? Why don't I try one more thing? And that is switching to a different charger. And that's what you can see here. It's SkyRC MC3000. That, generally speaking, is a charger for the cylindrical batteries, including lithium and all kinds of chemistries there. But hey, where's the will, there's a way. As you can see, there's equally junky wiring connecting it to the charger as there is connecting to the battery, so that's pretty terrible, but hey. So originally it didn't detect the battery and didn't want to charge it, just the same as the X6, because the battery was pretty dead. But I figured like, hey, after we did some bumping, maybe this one will do something differently from X6, because, well, different manufacturers, they have different algorithms for how they do things. And hey, lo and behold, after the bumping there, the SkyRC charger picked up the battery and we managed to charge it actually over several hours. I put, I think, 0.2, 0.5 even amps max for charging, and it did go for actually several, almost 10 hours, I think. And guess what? Like, I think the battery is actually holding charge now. Well, it's holding the voltage. I don't know how much capacity it is, actually almost nothing. Then I tried to do the battery discharge. It went down almost instantaneously. But the voltage is there, so why it might be important, I'll let you know in a second. But so let's see what the results of the charge is. So here's our results. So we're doing charge. The capacity is 1000, according to that. I think original one is about like 6000 or something, but it doesn't matter. Voltage 4.2, 4.2. So current amperage is, well, 0.6, 0.7. The thing is that I saw when it was charging, it only went up to 0.15, which is pretty low. So internal resistance is pretty high. So it's actually not a short. It seems like the internal resistance is very high, which is not unexpected. So I don't know how much it can discharge. So yeah, so it went for 9 hours, but again, it didn't terminate because of the low voltage. So yeah, the temperatures are not relevant. Yeah, almost 2000 milliamps. Again, in all fairness, the big chunk of that probably is the junky wiring what I have here. So take that with a grain of salt, even though I'm pretty sure the battery is pretty bad too in that respect. So anyway, so that's that. So I did manage to charge. You see the green light. I did reach the termination state, which is quite interesting. So if we just so now it's currently displaying the current voltage of the battery, and you can see it's 4.0, and it's not dropping as we've seen before. So yeah, that's the output of the battery. It's not charging anything right now. 4 volts is a good voltage for a lithium battery. So yeah, and nothing exploded. And let me just show you that it's really still the same battery. I mean, well, you'll have to take my word for that, but it's still part of the same skillet setup. Look at that, nothing blown, nothing is puffed or anything like that. The thing is, most of these devices, like mobile phones, laptops depends, tablets, even if you're actually okay with using it just with a cable, they wouldn't work if the battery is dead. So that's a problem, because if you can't replace the battery, for instance, the older device, or generally like, the batteries are not available, that's it. Even if you would be okay if using it on a cable, the device wouldn't be usable like at all without the somewhat working battery. And that's where this thing comes into play. So if battery is, well, from the device's perspective, working, it may have no capacity whatsoever, but it sort of passes the current and basically allows you to use the charger as a power supply, the cable as a power supply. Then that might allow you to use the device. Well, otherwise you wouldn't be able to. So again, all the safety disclaimer already mentioned, won't be repeating it again, but hey, using the deeply discharged batteries is potentially dangerous. So you're on your own there. That's your call. but it's an option. So this battery, I'm pretty certain, would allow us to use this iPad on a charger. And let's see if I don't want to reassemble the whole thing with this battery just to test that theory, but we may not need to do the whole thing. I might be able to just attach the battery to the main board and to the connector, and see if we actually, if the main board starts pulling some amperage, because that wasn't the case before. All right, and we're back. So here's a reconditioned battery that we extracted from the iPad, and after a lot of cajoling managed to actually get some charge in there. Just for kicks, let's see if it actually brought our iPad back to life, and if that would actually be usable. So let's quickly reassemble, or at least some parts of the iPad, and see if it actually helped. So that's the minimum setup. Let's see what does it do on the power consumption. Obviously we can't see anything on the screen, it's not connected, but we might be able to see something looking at the charger. Alright, so now obviously 0 amps. I haven't connected it yet, so let's see what happens. Oh, look at that. 0.66. So it looks like it's booting up. It's jumping up. Now it's down. Up again. These are significantly higher numbers than we saw before when we tried to charge. Before opening this up. Yeah, 0.7. Look at that. That actually looks like it is. The main board is actually charging the battery. Yeah, 0.66, 67. Yeah. These are good numbers. These are good numbers. We never got that far. And yeah, it doesn't drop to 0. Yeah. Nothing weird is happening. All right. So, okay. So I actually didn't plan to go further than that. But you know what? Let me just quickly connect this screen. I'm going to connect a whole bunch of other things. But screen, and let's see if we actually get this screen working and see if it actually shows the charging status and the battery percentage. I'm actually curious now. All right, so let's see. Should we try without the charger first? All right, let's do just that. Oh wow, we have a screen. Okay, it shows iTunes. It shows battery at half also. All right. Okay, how about we connect the charger. All right, so we have charger. Probably can see from here. Yep, right there. Alright, so now I'm disconnected from the charger. And let's see. So we just turn it on. Again, not connected to the charger. And look at that. We're in. The battery is alright. Let's see if I can. 60%. Can do unlock. Unlock works. Touchscreen works. So yeah, let me just zoom in the battery here. Yeah, 60%. And right now, let's connect it to our. Alright, so you can see it switches to charging. We are pulling 0.48, 49 amps, just fine. And again, as I said, I can disconnect now. And we're still on, so I'm not immediately draining the battery. It's still 59 now. So yeah, it seems that the battery is functional, actually more than I expected. Again, I could run probably a few more tests to see how much the actual charge or actual runtime can I do, but hey, you know what? Probably some other time, because as I said, I already have the new battery. Where is it? Yeah. So, which I'm going to install here. If I would have the new battery, I would consider running it like that, because it seems to be functional. Again, that's in this case I would test how much actual runtime is there, but for running on the charger, certainly works. It certainly runs somewhat on the battery, so how long that's gonna last, well, I don't know, probably not very long, but you know what, it's an old device. It's basically either throw it out or try to do something with that, like that.